Thank you very much. We will start right now. Welcome back to the third day of the JMark user conference and our fourth and last session of the day. My name is Anbu and I'm here to present our next speaker and my colleague here at PowerSys Frankfurt, Mr. Ahmed Shoaib. Mr. Ahmed Shoaib will discuss the efficiency map generation considering hysteresis and eddy current loss distributions. Mr. Shoaib is working at PowerSys since April 2019 and is our is responsible for JMark software, and he's in charge of customer trainings, webinars, and he's the first guy in the DACH area when you have a question regarding JMark. Please welcome Mr. Ahmed Shoaib. Mr. Ahmed, I will give you the screen.
Yeah, one moment. I hope my screen is clear now.
Yes, we can see it.
Perfect. Thank you again for the introduction. Thank you everybody for joining my presentation today. Today I'm going to be talking about efficiency map generation considering hysteresis losses and eddy current loss distributions using the plane model and 1D FEA. This is a continuation of, or sort of an application of what JMag now offers when it comes to efficiency map generation. So, sorry. Yeah. So my agenda today, I'm going to be giving a small motivation. I'm going to be describing the motor. Then I have a so-called base model. I will show the efficiency map generated with it. Then I will be explaining the equivalent circuit method. I will be comparing loss models on 2 operating points. Then I'm going to be generating an efficiency map using the equivalent circuit method. And then finally, I'm going to give a short summary of my work. So for motivation, so drive motors have achieved efficiencies of up to 95%. And now it's become more paramount to calculate, to consider not just to accurately calculate the losses, but also to take into account control circuits and motor control. However, the problem is that control circuit simulations are very time consuming, and we are now facing a challenge of finding an evaluation model that can calculate not just efficiency maps fast, but also accurately. So going quickly through the motor. The motor to be evaluated is a 3-phase PMSM. It's 8 poles, 48 slots. The rated output power is around 80 kilowatts. The DC voltage is 600 volts with a maximum phase current of 250 amperes and a carrier frequency of 6 kilohertz. So now I have my so-called base model, and I'm going to be showing its efficiency map. So for my base model, I'm using a sine wave drive. I'm using conventional methods based on the Steinmetz equation to calculate iron losses. Copper losses in the coil and magnet losses are not considered in this method. The reason why I'm generating this efficiency map is to have a quick evaluation and understand motor behavior over the operating range. This efficiency map does not take any time to generate. It takes around a few minutes, but it gives me an initial indication of how everything works. So now I'm going to be going into the equivalent circuit method. So as I previously stated, control circuit simulation is very tricky, and high carrier frequencies require very small time steps to capture all the harmonic effects. In addition, one needs to calculate several electrical cycles because of the voltage supply. We have an initial transient state in the beginning of the simulation. This can cause very large simulation times. The idea now is to use something called an equivalent circuit method, which uses a high fidelity spatial harmonic model for the initial transient period. How does this work is through this circuit here. What I want to highlight is that I do not just have my FEA motor circuit here. I also have my high fidelity motor here. And what does the circuit do is that here I have a normal PID control. And in this PID control, feeds into either the RT model or the FEA model. This is done. So in the beginning, what happens is that in the RT model is being used for the initial transient period. Since the IT model has inductances and torque saved, we get a quick calculation in the beginning. And then once steady state has been reached, this is determined by a certain tolerance. I move on to my FEA model. So here are some result examples. As you can see here, there's this line. This line shows the time-saving effect when using this high-fidelity model at the initial period. So there is no transient effect in the beginning of the simulation. So circuit current, as you can see here, considers the inverter harmonics, also the torque, but it's all in steady state. So now I'm going to be comparing loss models on 2 operating points. So as you can see here, I have 2 operating points, one at 2000 RPM, one at 9000 RPM. Both have 50 Newton meter output. To reiterate, I have a base model which uses a sine wave drive. It uses conventional method based on the Steinmetz equation for iron loss evaluation. I have AC copper losses, and magnet losses are not taken into account. For my high fidelity model, I'm using the equivalent circuit method. I'm using a PWM drive. I'm using the play model and 1D lamination method to calculate for iron loss evaluation. AC copper losses and magnet losses are taken into account. Here I show my results. So as you can see here, for the hysteresis losses for the first operating point, there is no change. There's an increase in eddy current losses. And as expected, copper losses for the copper losses and magnet losses are increased because I'm now considering them in the second calculation. For the second operating point, there's a slight increase in the hysteresis losses, and as normal trend, eddy current losses, copper losses, and magnet losses are increased. So why does this happen? So first, I consider hysteresis losses. So the play model is able to accurately reconstruct hysteresis loops. The figures below show the hysteresis curves at the tooth edge on the 2 operating points. The one on the left is for operating point 1. The one on the right is for operating point 2. The reason why I don't see an increase in hysteresis losses for the first operating point is, as you can see, yes, there are a lot of points here that are coming out, but those are not closed loops. And unfortunately for the solver, this detects that there's no increase in loss. But as for the second operating point, you can see that there are closed loops and it considers that as an extra loss. For eddy current losses, I see an increase in eddy current losses due to the carrier frequency harmonics. However, increase in eddy current losses due to the carrier frequency harmonics, which are not in line with the slot harmonics. So for the first operating point, I have my slot harmonics at around 1,500 Hertz. I can see here the initial component of the carrier frequency at 6,000 Hertz, and then the second harmonic component of the carrier frequency at 12,000 Hertz. As for the second operating point, my slot harmonics are at around 7,200 Hertz. This sort of does a blended effect with the carrier harmonics. So since they are quite close to one another, and the effect is not really pronounced as in the first operating point. Lastly, I want to check the AC losses. So the increase in AC losses at high speed is due to the eddy currents generated by the leakage flux. And I wanted to check which harmonic component is responsible for it. I do a quick FFT to see the leakage flux, where I find that the leakage flux is mainly caused by the fundamental wave and not the carrier frequency. Moving on, and then after comparing both loss models and seeing that I can get a better understanding of the physics, of losses with the play model and the 1D FEA. I generate an efficiency map considering using these new loss methods, and also considering the equivalent circuit model, so that I can consider also PWM losses. And this is how my efficiency map looks like. Now to give a quick summary of my work. So the equivalent circuit method saves a significant amount of time when it comes to calculating control circuits and efficiency maps. Control circuit simulation is necessary in capturing all the harmonic losses. The play model and 1D FEA method give a better insight into the physics of the losses, such as minor loops and skin effects, than using conventional methods based on the Steinmetz equation. For future work, I will be considering the press effect. I will be verifying this with a 3D model, and I would like to implement this workflow on a client motor and compare it with measurements. My presentation is quite small and quick, but thank you for listening. If you have any questions, please feel free to ask. Thank you.
Thank you, Ahmed. We will start with the question part right now. So far, we don't have any questions, but we'll wait a couple of minutes, so we give everyone a chance to ask their question. We have a problem with the audio, as I think, in the beginning. So, Mr. Urin, you can, okay, you cannot hear me, but I will just say that you can rewatch the session, then we will upload it.
In case anybody has any problems or needs further clarification, everybody has my email, so they can just directly contact me, and I can give them. We can have like a short meeting to explain everything, if needed.
It looks like we don't have any questions, but I would suggest we will wait 2 more minutes. Maybe something comes up. In the meantime, I will share the schedule for tomorrow.
Oh.
So, did you receive a question on it? Because I don't see one so far.
Yeah, I think there is.
Oh yeah. Sorry, I may haze misses. Did you run accuracy efficiency map?
Yes, exactly. This is an both are like the efficiency maps that I'm showing are accuracy mode. I think also we have an efficiency map session, a poster session regarding efficiency maps, where people can have an interactive discussion on how to generate efficiency maps, how to, let's say, how to consider all the effects when generating efficiency maps. We have an interactive session on Friday with my colleague Eve at 12 p.m. People can log on and interact with that.
Second question is, how many points did you run and how long does it take?
So I run around 300 points, and it takes, for the equivalent circuit method, 2 days. So it's not like within a few minutes simulation, but you can get results within a reasonable amount of time.
Okay, next question is there any info about the vector plane model in JMAC document?
Sorry.
Repeat it again. Is there any info about the vector plane model in JMAC docu?
I have some information I can send it. Like I have some documentation that I can send. Just please send me an email, and I can answer that. I have a lot of PDFs that can explain everything.
It is from Wan Yan. I can connect with him on Bova and give him your email address.
Exactly. Just send me an email, and I can give a detailed explanation of everything.
Okay. Next question from Jorge Roja. Did the comparisons made indicate a percentage difference in the nominal efficiency of the motor for the cases studied? What values? Sorry.
I think I need to indicate percentage difference. So the differences in percentage is around 2 to 3%. Of course, because you're using different methods, you're always going to have a difference. That's why I didn't show the difference between both efficiency maps. But what I wanted to highlight here is that using the plane model, I get a better understanding of the physics of the losses, and not just say, okay, this is more accurate, but just I have a better understanding of what hysteresis loops are created within the simulation, and get a better understanding of the eddy current losses. And from then I can continue working. But of course, when you're using different methods, you're always going to get a difference in efficiency percentage. But let's say in theory, the plane using an efficiency map with the equivalent circuit method with like my high fidelity model, this should give you very accurate results, and then you can just directly compare it with measurements afterwards.
All right, we have another question from Yves. Does the generator mode is also available in the accuracy mode?
Yes, you can do generator mode as well. I was more interested in motor mode just to have like a base simulation, but you can also do generator mode.
Okay, that was, I think, the final questions. So if you have any more questions, use the last chance to ask. If the question is quite complicated, you can also send it afterwards via mail to Ahmed. And
as I said, on Friday, we have a discussion about efficiency maps. Please feel free to join, and we can discuss more in detail.
Okay, we have another question. Is the high fidelity model circuit available as a template?
Yes, we have some circuit templates that we can share. You just have to create the RT model yourself.
All right. So I think that it is. Thank you, Ahmed, for answering all the questions.
Thank you.
And I will share the schedule for tomorrow. So this was today the last session, and we will continue tomorrow very early at 10 a.m. with a spline-based freeform shape optimization. Then at 11 a.m. we have PSIM implementation for modeling the solar-based grid-fed converter. At 12 p.m. we have simulations for the design of supercapacitor-based energy storage in a large scientific facility. And then comes the break, and at 3 p.m. we have the last session of tomorrow, experimental platform for the study of impact of rooftop PV system integration on distribution grid. All right, so tomorrow please join in an hour earlier than today, and yes, hope to see you there too. And thank you, Ahmed, again, and thank you all the viewers for being so loyal and joining in the afternoon, and I hope I will see you tomorrow too.
Yeah, thank you.
Bye.
Bye.